Hello guys, today I will be discussing you about my project NLPTasker. The aim of this project is to extract and categorize annotated text. So without further ado, let's dive into this project. So what we are trying to do here is take a input of a paragraph or a text, and then what we'll do is extract the entities and the task assigned to the entities and the deadline assigned to them. So basically he has to go to school, so he has to go to school tomorrow. The task is he has to go to school, the guy is he, and the deadline is tomorrow. So for this we'll be using a heuristic method. So we'll be using a heuristic method where we'll be defining a rule-based approach to and using NLP to extract text and then categorize the data. We won't be using any LLMs. So first thing first, let's go and understand the project first. Uh, so uh, these are the libraries that we will be using. SpaCy, NLTK, NumPy, sklearn. So spaCy for natural language, NLTK for stopwords, for regular expressions, NumPy for numerical related operations, and then sklearn for models. So first thing first, we'll import the necessary libraries, and then we have what we are doing here is we are already defining some pre conditions for our task. So some like verbs can be buy, clean, imperative verbs, so clean the house, go to school tomorrow. So these are some imperative verbs, and then we have some task phrases. We have also defined need to, has to, should, so that will help us identify the task. So whatever input we get, the first thing about any project related to machine learning NLP is to pre-process the data. So let's say the data is already useful that we got, so we are pre-processing the data. The first thing is like we'll take all the paragraph, convert it into individual sentences. Then we'll do some lemmatization where we turn the words into their root words. We'll remove the stop words, of course, the, is, and then we're also doing some filtering of verbs, noun, proper nouns. So this will help us understand the task, and then we'll output the both processed version of each task. So here's the function for that. You can see we're categorizing verb, noun, proper noun, removing the text. So once that is done, once the input is pre-processed, what we'll do is we'll try to extract the deadlines first. So to extract the deadlines, we'll look for regex matching. So we'll look like for patterns like by, until, on, before, like such words to understand what can be the deadline. Once that is done, we'll try to also look for some keyword matching. So that alone won't help us. We'll do some keyword matching, like we'll use the word like today, tomorrow, next week, this week, Monday, Friday. So once we've extracted the deadline, we'll need to identify the task. So to identify the task, we'll check for the imperative verb we declared earlier. We'll check for the task phrases. Then we'll try to extract the entity using spaces. And then we'll try to extract the subjects as fallback. So in case there is no entity present, entity as in a name or a person, we'll try to fall back to the subject like he, she, or anything, I. And then we'll try to extract the deadlines using the function we declared earlier, and then we'll store the results. So I've added some print statement to understand what exactly happens in each and every functions. So we're matching the verb, we're matching the task, we're matching the is it a match, so we'll identify the task or not, and then we'll try to save them. So when we're doing this, we're trying to also print out the values of what actually is happening. So now comes the part, categorization. So categorization, like once we have extracted the task entity, we want to categorize it. This a personal task, this a professional task, is this administrative task, or a team task. So there are two methods to do this. One is topic modeling, LDA, latent direct allocation. or we can use the word embedding method. So basically, the entire process remains the same, only the categorization part changes if you use the word embedding method and the LDA method. So in LDA method, what we are doing is we are first using TF-IDF vectorization. So this means term frequency in inverse document frequency. So we're trying to see how many times the number of terms occurs in a particular given document. So to do that, we'll convert each and every word to numbers, and then everything happens behind the scenes. So we're calling the model. We've used the feature 1000, and then we'll try to fit and transform those process sentences. And then once we have the vectorized form, we'll try to input them in the LDA model. So once it goes into the LDA model, we've declared 4 components because we would categorize it in 4 parts: professional, personal, team, administrator. Um, it will later, the model will later categorize it. Now the same approach can be used using NLPTasker, using word embedding. So what word embedding does is we'll train the word using word to vec model. So this creates embeddings for each and every words in your input text. So once that is done, the embeddings are later used in k-means clustering to group the relevant and similar looking categories into one category. So again, here also we have defined the same categories like before, and then we're creating the embeddings, and then we're clustering. So before training, so first we'll need to train the embedding using this function. We train the embedding using word to vec model. Once the model is trained, the embeddings are returned. We are using the same embeddings to classify it using k-means. And then again, similarly, the same process again happens. We're extracting the task, we're storing it, like we have a function to extract the task, everything over here. Once that is done, we have a function def main where we have the actual input, and then what we are doing is we're calling the function. We're orchestrating the entire process. So here you can see this is the behind the scenes that was happening. So you can see Rahul wakes up early every day. The process sentence that happened uh, after our regular expressions, and those imperative verb detection and all. It called weekday, imperative verb detection, task space. So not a task skipping. So similarly, it identifies the other task as well. These are the behind the scenes what's happening. So when that is done, this is the final output. He goes to college in the morning, comes back at 3 p.m. He non-professional, so it wouldn't identify this. So we have John needs to review the report by Friday. John, deadline, administrator. So this was the notebook to understand the entire process. Now we've created a simple professional structure to ingest the data through here, data.input.text. Here we have basically the same input. We have a folder to store our logs, those print statements that I showed you earlier, and then a folder to store our output. And then we have our folder task instructor where we have uh, 4 files mentioned here. So init is basically to let the code know here is the source. So here's the extractor.py. It's basically the same functions. We're importing everything here. We're trying to again declare the imperative works, task phases. We're pre-processing the text. We're identifying the task like same like before, extract task. And then we have another folder called models. So here is the LDA part, and I've also included a word embeddings plus clustering. I've commented it out. You can try it out if you want to. So here's the models, and the utils.py contracts the extract deadline part. So this code is doing the deadline extraction part. So I basically modularized the notebook into multiple different codes, so it will be easier to make changes if you want to. And then all this is also orchestrated using main.py. The whole process gets orchestrated using this process. So we are inputting the data text using from here data, and then we're calling our functions, text extractor. From here we're calling our functions, to extract the text. Once that is done, whatever output come, we'll try to save it as a CSV file. So we've also added our logs. So we've also added a separate file called logger.py. This is like basically configuration your login aspect. I've added a simple part. So this will help us store all the logs in this folder. So let us go ahead and run this file. This file now simply will do the entire process at one go. So we can consider this as a simple NLP pipeline. So when we run this file, let's go ahead. We can see the logs have been created. We can check for, yeah, the output.csv is also created. The code has successfully run. Let's go check out the log. So yeah, the log is exactly like the print statements in the notebook. So it's process in less than 10, identifying the task. You can see the logs were created now at particular time. And then we can check out the output. The output's here. Sarah has to prepare for presentation for the meeting on Monday. So yeah, it's been extracted: task, entity, deadline, category, process, task. Can we see it in a better view? Not really. Yeah, so this was the project. I hope you like it. I've also added a detailed guide on how this project works and everything over here in a readme file. The GitHub link will be provided. Do check it out. Thank you.